Hi, it's Mrs. Scarpel, and we have the second part of the first lesson for Unit 2 covered in this video. So in Part 1, we were looking at transformations of quadratic functions. And in this video, we're going to remind ourselves of what those transformations were, and we're going to apply them in part of our retrieval, because we can also apply these transformations to linear functions. It doesn't just have to be for quadratic functions. And as you follow your course path through math, you'll see that it gets used with other functions as well. So our first function transformation that we looked at was when we added k. So when we added k, the graph shifted up when we were adding. So the graph shifts up when adding, and the graph shifts down when subtracting. When we decide to subtract from x before we square it, this was when we saw the graph shift to the right. When we added to the x before squaring, the graph went to the left. We also looked at what happens when we have a negative in front of our x squared, and this causes the graph to reflect across the x-axis or over the x-axis. And then we saw when we multiplied x squared, if the value of a is greater than 0, then there is a vertical stretch. If a is between 0, oh, excuse me, that shouldn't have said if a is greater than 0. That should have said if a is greater than 1, then there is a vertical stretch. If a is between 0 and 1, then there is a vertical shrink. So when it's a stretch, we say that the graph narrows. And when it shrinks, we say that it widens. Some additional vocabulary and notation that we used in this lesson. The vertex is the point of the maximum or minimum. The line of symmetry is the vertical line that passes through the vertex. And what it does is it makes each side of the graph the same. So let's do some more review here. Here, for example, we have a line of symmetry for this parabola. As I mentioned before, it's the vertical line that divides the graph into two congruent halves. It's sometimes called the axis of symmetry rather than the line of symmetry. The equation for the line of symmetry is always x equals the number. So if you see here, we have x equals -3. That's because our vertex has an x value of -3. So this line of symmetry is passing through that point. And the stretches that we talked about, the geometric term for that is dilation. It's considered a non-rigid transformation because our graph does change shape. So when a is between that 0 and 1, it's going to be wider. It's going to look like it's shorter. And then when it's larger than 1, it's going to grow faster and it's going to look narrower, like it's been stretched. Then we have our vertical and horizontal translations. That's what these shifts are called. So when k is greater than 0, we go up. When k is less than 0, we go down. I need to fix something on this slide. This should say x plus h. So when h is greater than 0, we go to the left, and when h is less than 0, we go to the right. And then when we have the negative, we reflect over the x-axis. It doesn't matter what the graph looks like. So here we have a curve. This is actually a curve for a cubic, one that's to the third power. And the green is the reflection. So we just reflect over the x-axis. So in our retrieval and in your assignment, you will have some of this. Draw a line of symmetry for the graph. State whether the graph has a maximum point or a minimum point and provide the coordinates for that point. So we have, usually that line of symmetry is drawn as a dashed line. So that's like our mirror for the two sides of our curve. Because this graph comes down and then goes back up, we would say that this graph has a minimum. We can say that it has a vertex, which is that minimum point, of 4, 0. And I know it's not on here, but it does appear on your assignment. The equation for that line of symmetry is x equals 4. It matches the x value of that minimum point. When we look at this second curve, it increases and then decreases. So our vertex is up here. Line of symmetry is drawn right through it. It's a vertical line. This vertex, we said, because it's at the top, is going to be a maximum. its vertex is located at, so here is 0, 1, 2, 3, negative 3, 5. And if we write the equation for the axis of symmetry, that's going to be x equals negative 3. The x of the vertex always matches the equation for that axis of symmetry. I mentioned earlier that the transformations for quadratics also work for lines. So I'm going to put my axes on these graphs here quickly. So for this first equation where we have negative 4 times x plus 3 plus 7, I'm going to start by going to the left 3. So from my origin, I'm going to go 3 to the left, and then that plus 7, I'm going to go up 1, 2, 3, 4, 5, 6, 7. The negative 4, because this is a line, is my slope. And we can think of that as negative 4 over 1. So when we find our next point, we would go down 4, right 1. Down 4, right 1. And I can keep doing this before I graph my line. And there we have our line that passes through negative 3, 7 and has a slope of negative 4. This second equation is in what we call standard form. When you have an equation in standard form, an easy strategy for graphing is to find the x and the y intercepts. So I'm going to start with my x-intercept. Now my x-intercept is going to be somewhere along my x-axis, and the value of y for any point on this axis is 0. So I'm going to take this equation and I'm going to replace the y with 0. Well, 4 times 0 is just 0, so I'm left with 3x equals 24. Divide both sides by 3. And we have x equals 8. So I can plot that point on my x-axis. 1, 2, 3, 4, 5, 6, 7, 8. For the y-intercept, that's going to be found on my y-axis. And the x value for any point on this y-axis is 0. So this time I'm going to replace the x in my equation with 0. Three times 0 is 0, so we're left with negative 4y equals 24. Divide both sides by negative 4, and we have y equals negative 6. So I find negative 6 on my y-axis. 1, 2, 3, 4, 5, 6. I have 2 points, and I can graph my line. And that is how you can graph a line from standard form. So this was how we wrapped up lesson 1 from unit 2, introducing the transformations of quadratic functions.